Moving on then, C part 1. What name is given to a nuclear process which takes place in the core of a nuclear power station? That one you should know very clearly is nuclear fission. The fuel used in a nuclear power station is often an isotope of uranium. Describe briefly what happens to your uranium nucleus in a power station. So we're interested in particular in what's happening in the nucleus of the uranium. Well, we're talking about fission here, and fission means splitting or breaking apart. So the nucleus of uranium splits and it releases energy. And it's this energy that is then harnessed to create the electrical power. D. What name is given to the nuclear process which takes place in the core of a star? And remembering that a star is similar to the same process what happens in our sun. Nuclear fusion. And moving down to more specific details about that nuclear fusion that takes place in the sun and any star, what element is the fuel used in most stars? It's hydrogen. It's when two hydrogen nuclei join together and give out energy, and in joining together they form helium. But be careful here, you must put hydrogen, not helium. Helium is what's formed as a result of the reaction. So you must focus on your answer. The fuel used in the reactions in the star is hydrogen. Part E then. In 1910, a historic experiment was carried out to find out more about the structure of the atom. In the experiment, alpha particles were directed at a very thin gold foil. Two observations were made here. Most of the alpha particles passed straight through, some with no deviation and some with a small deviation. And observation 2, a few were deflected back toward the source of the alpha particles as shown in the diagram below. So you can see that most of the alpha particles pass through. Some of them which come close to the nucleus are deviated, and some which come very close to the nucleus or hit it square on are returned back or deflected back towards the source of the alpha beam. Part 1. What does this experiment tell us about the charge of the nucleus? So we're focusing specifically here on the charge. It tells us firstly that the nucleus is positive. Now there are 2 marks for this question. There's your first mark. The next mark comes for explaining your answer. The nucleus is positive as it repels the positive alpha particle. And you should know that alpha particles are positive. You could also put in there that light charges repel, and that would give a very full answer. So 1 mark for identifying that it's positive, and the 2nd mark for the explanation of the positive nucleus repelling the positive alpha particle. Part 2. Which observation indicates that the nucleus is small? Well, that's observation 1, which states most of the alpha particles pass straight through, some with no deviation, some with a small deviation. So the main bit out of that we use to support this statement is that most of the alpha particles pass through. And part 3, which observation suggests that the mass of the nucleus is much greater than the mass of the alpha particle? Let's go back to the observations again. Observation 1, most of the alpha particles pass straight through, some with no deviation, some with a small deviation. That's indicating something about size to us for the nucleus. Observation 2 then, a few were deflected back towards the source of the alpha particles as shown in the diagram below. So we're talking about this alpha particle coming in and being deflected by the nucleus. And which observation then suggests that the mass of the nucleus is much greater than the mass of the alpha particle? Well, it's observation 2. It says that the alpha particle, or a few alpha particles, were deflected back to source. This suggests that the mass of the nucleus is much greater than the mass of the alpha particle, because if the alpha particle were greater, it would knock the nucleus out of the way and pass on through. But that's not what's happening. The nucleus is staying put, and it's knocking the alpha particle back towards the source. So the alpha particle must be lighter. Therefore, the mass of the nucleus is much greater.